How's it going, guys? Welcome back. My name's Nick. I'm back here at NT Performance Engines with my friend Matt Trevina, and we're going to be taking a look at his 800 horsepower setup today. Alright, so I'm back here at NT Performance Engines with my friend Matt Trevina. He's done a little bit of work on his 800 horsepower setup for his KE. It's obviously been a while, he's been a busy man. So, what's been going on? You've mounted the pump, that'd be one of the first things, yeah?
Yeah, so last time we saw it, if anyone wasn't following on Insta or Facebook or anything, the pump was we were sort of just showing how it was going to be mounted, and now it's mounted. So there's a little bit that went into it. I'll pull the cover off here and we'll have a bit of a look. I've just got it dummy assembled at the moment so we can give it a cycle and see how it all works. There's no valve train in it. The head's only temporarily bolted down loosely. But what we've done is we've made I bought this piece off here. It's a distributor relocation from SQ Engineering, Sam.
Yep.
Machined out the inside to suit the receiver for the fuel pump, and then if you look in behind it, I'll even pull this off for us in the video and we'll have a look, but in behind there I've actually made a drive, if you look down in there, and that drive mounts directly to the cam. So yeah, the way it works is the cam gear is bolted on with a single bolt, same as here, and then on the outside of that I have a billet alloy receiver that I've machined up, and that goes over the outside of that bolt, and then that's bolted in 4 positions onto the actual toter cam gear. So I had to modify the toter cam gear, which is something I don't like doing because it's such a nice piece, but yeah. I've done it, and now it all sort of bolts up, and I'll cycle it over for you to give you an idea of what happens. So we've got a crankshaft in. There's no keyway in here, but it still sort of rotates over. But all I was trying to see is if there was any sort of resistance in the assembly, and if we cycle it over, everything sort of spins over pretty nicely. No sort of resistance, the pump turns over. There's no tight spots within the pump, so it means the pump alignment to the camshaft is perfect. So yeah, this is how it'll work in the car. Bit of a shameless plug here to Weld Speed. They're going to make me a custom intake manifold for this. It'll be a custom one-off item. It'll be a billet intake manifold with 2 fuel rails. Off my pressure side here, which will split into 2 lines, I'll have a set of Injector Dynamics 1300cc injectors and my billet atomizers, which are 1680cc on the bottom side. So 2 fuel rails, E85 fuel, and then that should supply me well and truly enough fuel to make the 800 horsepower that I'm looking for. Another little few updates on the oil pump side here. If we remember back in the day, we were doing a trigger arrangement, so I've actually incorporated a cherry sensor instead of the factory Toyota Hall effect sensor, and then that just comes down to the toothed wheel that I've mounted to the back of this factory gear. So yeah, and now I obviously have the adjustment in distance because I've made a receiver. I actually got that made up by a friend of mine, Alex Thompson at High Spool Industries. He does all my turbo work. Yep. Plugged a Tomo there. If you want a turbo done, he's the guy to talk to. But he basically just machined up this little receiver in here. I'm going to change this bolt out because it looks a bit rough, but that just holds the receiver in here for the cherry sensor. Now I actually have the option to bring the sensor in or out depending on the tooth height that I make. I might decide to go to a higher tooth to give me a better profile.
Yeah. You've already got one cut out too, haven't you?
Yeah, I've got a separate one. My separate trigger wheel is... there's more teeth on this wheel. So I have samples of both. This has double the amount of teeth, I believe. I can't remember how many teeth, 36 teeth, I think. Yep. And then that was a 12 tooth. So I got 2 types made up because when I test this on the stand, I'll basically be spinning it over with a flywheel and starter motor soon. With it timed in this fashion, no valve train or anything, no pistons and rods. And when I spin it, I'll actually put an oscilloscope on this and actually see and actually scope out my my tooth and see how I like the profile. And I probably won't be able to spin it to 10,000 RPM crank speed, but I'll spin it up and see what I like, and then if it needs to be changed, it's as easy as changing out the gear on the back to a higher tooth, less teeth, more teeth, whatever the engine likes, whatever the ECU likes rather, and the sensors, and then we'll go from there. Again, I'm still learning about this sort of stuff. It's pretty custom stuff, so it's not something that you just buy off the shelf. Yeah, no. So yeah.
So what was the difference with the sensor? So you've changed the sensor to this cherry sensor.
Yeah, so this is a Hall effect sensor, so a 3-wire. So we've got power 5 volts or 8 volts, and then we've got a signal ground and then a signal wire. So the powered sensor. The other sensor was a reluctor, 2-wire magnetic.
Oh, okay.
So as the tooth passes over, it creates a magnetic field, and the ECU internally will convert the sine wave into a digital square wave, and then that's what the ECU actually interprets into, you know, timing and things like that. Okay. This actually is a digital square wave input, so there's no conversion from a sine wave, it's an actual square wave. Okay. So yeah, so this is a bit more accurate. This only does my crank speed. The next point of attack will be mounting a magnet inside this timing gear here. I'll probably be drilling a small hole and inserting a neodymium magnet into here, and then through here I'll probably put a small sensor in which will also go through that hole here and then read the small magnet, and then that will be my home position.
Well, that's going to be neat.
Yeah.
I remember you were almost ready to cut that off as well.
It was, yeah.
Lucky you didn't.
Yeah, so I didn't do it because this might have been the case. The other thing I was considering doing was using a factory, this one's torn apart, but using the 20 valve factory cast sensor. I've removed all the reluctors out of here and just got this piece remaining. What I was considering doing was using this housing, cutting the shaft down and actually mounting a single tooth point off this, putting a cap over, drilling and tapping into the side and putting another Hall effect sensor directly in to read that single tooth home, just using this in the bearing and the drive, and then just mounting it on the back. Yep. That's also a neat system. If I do that way, I can actually lop this off and make it look a little bit prettier and whatnot. But I
think I prefer this system, to be honest with you.
It's going to look pretty trick on the front too. Yeah. It just depends if I can find the right size Hall effect sensor, something cheap and readily available. But yeah, I'll pull this pump off quickly and show you the adapter I made, because it's a pretty cool bit of thing. I'll just grab an Allen key. Alright, so we've loosened off this. So the way that's designed, that it's actually, you can modify the depth that it runs. Obviously you want to run it in as far as possible. This is the spline drive from the fuel pump, and the receiver that I've made actually is in here, and you'll see that there's I think it's 7071 grade that I used, or something like that. It's a billet alloy. It's pretty strong. It's strong as steel actually, and then that just bolts to the front of the cam gear. So it's a pretty simple setup, like you say. It once it engages, you can run the pump any direction you want. This direction for me is probably going to be the best looking. So in the most aesthetically pleasing way, I guess. And yeah, it's just a simple clamp arrangement that just bolts on here, tighten that up, and the pump's on. Easy to service, I guess. I've seen a lot of the drag guys do it this way. A lot of the drag setups that I've done with 2Js and 4 RBs and stuff, they all do it the same way.
That's very simple, man.
Yeah, so nice, neat, tidy little setup. Aside from that, what else have we got? That's about it. I've just sort of trial fitted my water pump and water snout. This is Floss from Ireland. He makes mad. They were originally the RS Chitta rear-wheel drive water arrangement. It looks like Floss has probably bought the patent and redone it. Unbelievable. I can't believe people are still doing these, because I thought I bought the last one from Japan many years ago, and I thought they'll never make these again, and Floss has come out and killed it. The casting on it's beautiful, the alloy quality is amazing. It's the neatest way to do a 4A 20 valve is by far rear-wheel drive water pump with a Floss top snout. Just beautiful. Aside from that, what else have we got? We've got rear head drain. So this is the rear head drain that I do on 20 valves and big ports. Same deal. So there's an oil orifice in here that you can tap into. That just turns the corner, and I'm going to put a bit of line in between here and here. And that's just my rear head drain. That gives me really good oil drainage ability from the back of the cylinder head in the 20 valves and 16 valve big ports. Terrible oil drain down from the head. So with this rear head drain, it allows you to just get it straight down back into the sump, so you don't cavitate. And there's been a lot of misconceptions with oil pumps breaking in 4As. People seem to think that it's because there's not enough oil pressure, or for whatever reason they believe that the oil pump gears are weak. It's completely not true. I run factory oil pump gears in my own engine. I've revved it to 10,000 RPM. So my understanding of it is they're cavitating, they're over speeding the oil pumps, draining the sump dry, and as it picks up air, and then as liquid starts to get into the pump again, the oil pump gears actually belt against the snout, the drive snout on the actual crankshaft, and then eventually the chattering on those gears just has them explode. If you have a constant supply of oil pressure, you won't have that problem. So one of my recommendations on 4As, 7As, 4As, is don't overpressure your pump. Leave the factory spring, oil pressure relief valve spring in it. Leave it factory pressure, and get as much oil from the cylinder head back down to the sump as best as you can. So rear head drain, lightweight oils, nothing thick. Let it get down to the pickup, because you want your oil in the sump. You don't need oil pressure, a crazy amount of oil pressure to run an engine. You need like 40 pounds of oil pressure up to 8,000 RPM, and then for every 1,000 after that, you need another 10 pounds. Yep. So you probably only need 60 to 80 psi of oil pressure to run an engine to about 10,000 RPM, a 4A.
But it just needs to be constant.
Yes, it has to be constant. Yeah. It's very hard to see cavitation in a oil, like a data log for an oil pressure. It's very difficult to see unless you're logging very high hertz channel, and you've got, it's very difficult to see the fact that you're cavitating. So, I mean, I've seen this. I've seen a few oil pumps break, but it's all been down to cavitation. No rear head drains, things like that. Too thick in the weight of the oil that they're running. I run next to like water almost. Depending on the season, I blend my Brad Penn engine oil. So yeah, rear head drain, way to go.
That's actually a question I've had. I've actually had a few people ask me on Instagram and on YouTube, what kind of oil do you guys use? What kind of oil do you recommend?
Brad Penn. So here's a bottle here. This is a diff oil I run in my diff. This is a Hypoid synthetic blower racing lube. So this is really, really good for diffs. It's a GL5 rating, so good for diffs and good for gearboxes. This is the brand of oil that I run in any of my engines. I only run Brad Penn. I used to be a Royal Purple guy. I used to find 1 track day and a bit of street driving, the oil was burnt. This stuff I can do 7 track days, 1,000 Ks on the street, and on an ethanol car, it doesn't even discolor. It stays beautiful green, and it doesn't burn. Yeah, it's just really, really good. I actually drain it out of my race car and put it into my daily driver. Yeah. So, yeah.
What was the go? Was it a high amount of zinc that's in the oil?
Yeah, what has it got? It's phosphorus zinc, I think it's got in it. It actually looks, I've had customers call me up and say, man, look at my oil, there's all this glitter and stuff in it. I'm like, dude, relax, that's the fuzzy zinc in the actual oil that helps drop temperatures down. That can obviously absorb the temperature from the friction surfaces in the engine, and then it absorbs the temperature and then relinquishes it a bit better in the sump, I believe. Again, like you say, I've done oil testing on this with like companies like, I can't remember the name of the companies that I use, but I do like oil testing and send off samples, and mate, it always comes back perfect. This stuff's just, it really, really works well. I wouldn't use anything else.
Yeah, it's good stuff.
Yeah. Cool. Outside of that, what do we got? We got the dog box sort of coming along. We'll pull this out. So this is the gearbox that's going to get mated to that engine. Yep. The last time we seen it, I don't believe the shifter was mounted.
It wasn't. This was 3D printed. It wasn't.
Oh, that's right. Okay, so the 3D printer's been finalised, and I got this made in billet. Again, pretty high grade billet. Yeah, so it's mounted all up now.
You also shorten these
and shorten the shift shafts down. Yeah, so these have been shortened down to meet up with the linkages, because they were obviously, the shifter was offset further back.
Yep.
The distance between the exact center line of this shifter in neutral, which is there, the distance between here and the front of this, the face of this bell housing, is exactly the same as a T50 now. So the overall length for center to shifter and that is T50. So this should theoretically bolt straight into the car. This should come up in the factory hole position. So really, really exciting for that. But yeah, so just a quick demonstration of how it all works. So it's a pretty cool system, obviously being an ex-NASCAR gearbox. You come across and forwards to first, back down to second. Now if you just push forwards, it clicks over to the other side, and you just push forwards to third, and then back to fourth. Reverse is from neutral, you push down on the shifter, like down, down and then across, and then that's reverse.
Yeah, it's really cool.
So yeah, so there's no chance of you going, so if you come first, second, if you wanted to go to third, there's no chance of a second, first, second, first. It's, hold on, let me just turn this input shaft and get the dogs lined up. So
yeah, that's what I was trying to get a visual of, that spring that you're about to...
yeah, so if you actually watch, I'm just going to push this forwards, I'm just going to slam it, that's third. So it didn't come across because of the spring on this side, it actually pushes the shifter over to third.
Yep.
So coming from second over to third, you physically cannot go back to first unless you push hard left on it.
Yep.
So there's no chance of this ever doing a first, second, first. It'll only go first, second, third. So pretty cool feature about the box, especially since I'm going to be drag racing the car and even drifting it. It'll be all second, third, fourth stuff. So drifting and drag racing and stuff. So you'll never really need to go back into first unless you're starting to come off the line. So like you say, from first, second, and if I just push forwards, just go straight to third. Yeah. So yeah.
It's good how they put reverse up where first would be too.
Yeah, it's actually a pretty cool feature. So this is based off a Ford top-loader gearbox. So you can see that we've gone around this in one of the other videos in the past, but basically it was a side shifted mechanism. That's all been moved to the top by Roush Racing in the States when it went into the NASCAR, and then they had the shifter obviously set way further back to suit their NASCAR. I've just moved it forwards, made it all work. Bell housing to suit 4AGE, custom made this one myself, and yeah, I've got a direct twin plate clutch going into it. Just a few pieces coming around for it. So on the inside here, my bearing retainer in the front, that's going to be changed over to tilt-on, where I'll be able to mount a tilt-on slave cylinder up to suit the twin plate clutch.
And don't worry, he's going to powder coat it.
Yeah, no, this is just, I'm not going to make it look pretty until I drill holes and all sorts of things. I need some cooling holes, and then back here I'm going to put some hydraulic lines coming out because it's going to be a concentric slave cylinder. Yeah. So I'm going to put some quick connect lines onto this. So I'm not going to powder coat it until I drill it all and make it,
You use dry brake lines, don't you?
Yeah, dry brake. It's a European brand, Stable or something. I can't remember the name of the brand. Motorsport Connections sell it to me. But yeah, complete dry brake system. So it's just push, twist and pull, and no bleeding required. So when I do the gearbox, when I pull it out of the car, you can literally dry brake the clutch line and gearbox comes out and the clutch slave stays bled. So when you go to put it back in the car, you slam it back in, dry brake on, press a clutch, and it works exactly the way it did before you take it off. So really good for service work. Normally, if you've got like a clutch slave pushing on a pivot fork, you have to unbolt the clutch slave. That's just another task that is just painful to do, especially if you're at the racetrack and you need to pull a gearbox out to do whatever. Say you've, I don't know, melted a clutch or something and you're trying to get the clutch plates off to change them out. This is a very easy system to just dry brake, remove, gearbox bolts, cross member, tail shaft out, box out. It's a pretty quick, simple task. If you've ever been drifting at a professional event, you'll know how many times a gearbox comes out of an event, especially if you have clutch slave problems. So you just try and make it easier on yourself. So it's all coming together and it's not far off now.
I like how you've mounted it onto the stand as well.
Yeah, it's easy for service work, I guess.
Yeah, and I will say as well that the shifter feel is awesome. Like it actually feels really good.
Yeah, I'll put my foot on it.
It's an awesome feeling shifter.
Yeah. I can't wait till it's in a car and it doesn't have this annoying stand movement. It's gonna be nice to shift. And whenever you've sat in a dog box car and you slide it into gear and the dog sinks it in, it's like sunk, and it's just like, oh yeah, like it's ready to party.
Yeah, I'm looking forward to the clutchless shift.
That's going to be a cool thing too.
Flat on the floor with the accelerator and just jam into gears is going to be so cool. One
of the things I showed Nico off camera earlier was I'm actually making a strain gauge that will be mounting to this part of the shifter here, which is a digital, or it's an analog style system. Basically, it's a lot of wires, some I guess surrounded in some two double-sided tape. Is the easiest way to say it. That's what it is. But basically, what that does is that then goes to an amplifier, which converts the analog signal from a very fine, very soft voltage into an analog square, like an analog 5-volt voltage. That then gets interpreted by the ECU, and basically as you pull on this in a dog box car, if there's load on the box, the dog won't disengage. So it doesn't matter how hard you pull, if there's load on the gearbox, you cannot pull it out of gear. It's not like a synchro box car. Just the way that the dogs are designed with a backwards tooth on the dog, you physically cannot pull it out of gear. So what some people do is when they want a clutchless shift on a dog box car, is they set their limiter, and when they set the RPM limiter, they set it with a hard cut. Basically, if you pull the shifter and preload it, so you pull on it, when the second that the limiter pops, it selects the next gear. So obviously then when you've selected the next gear, the RPM drops down, so then it goes into the next gear. Sometimes you don't want to do that and you don't want to run it to the limiter, so what you do is you'll put in a strain gauge, and what that measures is the actual bending of this bar. Now, you wouldn't think that this metal bar would bend, but it does. And what that strain gauge does is it measures the amount of bend that's in. So I can program it to, say, shift at 20 pounds of force, 30 pounds of force. For us, what do we, metric system uses kilograms of force.
Yeah.
So
you just have to test it and calibrate how much.
That's right. So if I pull on the shifter and I find myself pulling too hard, I just keep amplifying how much strain is being interpreted until it shifts for me when I just pull on it. So you can have it as easy as I just touch it like this, it initiates a cut, and as long as I'm actually physically giving it enough force to actually fight the spring system and mechanism, it will shift. So you will basically want to program it so you can just grab the shifter and just pull it at any time and it will shift. It will shift cut and then shift gears. So I'll be mounting a strain gauge amplifier to this and setting it up in the ECU so I can just flat shift at any point in time. So you can just drive around and just go pop and then just not clutch, touch a clutch and just shift it. So yeah, it's getting there. I'm pretty excited about it. It's all happening. It's a neat little package.
Yeah.
Yeah.
And you're going to put the box on your 400 horsepower. So.
Yeah, I'll be testing it on the current engine in the car because I think this is probably going to be done before that. Yeah. I've just purchased a sump for this out of Moroso in the States. We've done like a group buy online for alloy sumps. So I bought one for this engine and one for a future engine that I'm building, which will be a 20 valve cylinder head, 7A block with a 4A billet crank, BME alloy rods and a custom piston combination, which then will supersede this engine, which will be the next 4A. It'll be a 7A block, 4A crank, 4A stroke, but it's going to be a billet crankshaft, custom crankshaft, which will have, it'll be a short stroke engine, long rod, short stroke. So it'll be able to rev whatever RPM I decide to spin to, 13,000, 12,000, whatever I can try and spin it to. So this one will come out at some point. When that goes in, that's when the next engine will start get built. I've always got an engine on a stand being built when there's one in the car. So yeah, I don't like not having an engine on a stand. I can't not have something that I can toy with on a stand. Yeah, whilst the car's still running. So yeah.
Well, that a bit for this video, guys. If you like the video, be sure to like, comment and subscribe. And if you'd like to see next week's video where Matt gives us a look at his customer's massive RB26 setup, be sure to hit that notification bell. And in the weeks following my visit to MT Performance, Matt actually sent me a couple of videos using his potato camera, just of this gearbox being finished up, getting ready to go into the car, so I'll throw those in here. Thanks for watching, guys.
Well, I got the bell housing back from powder coating, so it's all coated on the inside and outside's done. Mounted up to the gearbox, and the clutch of flywheel is mounted on this motor. So last steps before getting this in the car, bro.